Good afternoon, my dear students. Today I will explain Cauchy's integral formula in complex analysis. This is in Unit 3, starting. Cauchy's integral formula is if fz is analytic function everywhere inside and on a simple closed curve C and z0 be any point in C that is interior to C, then the function f of z0 that is the function f at z is equal to 0, z0 is equal to 1 by 2 pi I into integration fz by z minus z0 over C dz. Proof. Here given that fz is analytic function. Analytic function everywhere inside and on a simple closed curve C. And z0 is any interior point in C. So that is now we construct a new circle with radius rho, that is z0 minus z0 is a center point and z minus z0 is equal to, that is radius is equal to rho inside C. And then that we can write z minus z0 is equal to rho into e power I theta. We know that modulus of z minus z0 is equal to rho. Then we can write z minus z0 is equal to rho into e power I theta. So therefore z is equal to z0 plus rho into e power I theta. Then dz is equal to differentiate with z, dz is equal to z0 is a, since z0 is a constant, differentiation is 0 plus rho into e power I theta, differentiation is I into e power I theta into d theta. We have to prove that f of z0 is equal to f of z0 is equal to 1 by 2 pi I into integration fz by z minus z0. So consider this integration fz by z minus z0 dz. So adding and subtracting with the f of z0, f of z0, here we can write and dividing two parts, f of z minus f of z0 by z minus z0 dz plus next this part f of z0 into integration 1 by z minus z0 dz. So first we will find this integration. Here we know that z minus z0 is equal to rho into e power I theta and dz is equal to this one rho into I into e power I theta into d theta. So substitute here this one and cancel e power I theta and rho also we get I into d theta. This f of z, since f of z0 is a constant, we can write outside. So this integration is for I into integration is theta, limits are 0 to 2 pi. So applying limits I into theta, theta is equal to 2 pi I into f of z0. This integration is, we shall prove that this integration is equal to 0. How we prove it? We know that the function fz is analytic function. Analytic function means this is differentiable everywhere and also every differentiable function is continuous. As we know that fz is analytic function, then fz is analytic at z0 also and f0 is continuous function at z0. By definition of continuity, we know that modulus of this is equal to epsilon. We can write for every epsilon greater than 0, there exists delta greater than 0 such that modulus of fz minus f of z naught less than epsilon for all z minus z0 less than delta. So we can write modulus of this one is less than or equal to, we can write inside modulus. by before theorem. So dz, so less than or equal to, this is epsilon by, this one is rho into e power, the modulus of z minus z0 is equal to rho. So since modulus of e power I theta is equal to 1, so dz, when delta rho tends to infinity, this will become 0. Therefore, this integration with modulus tends to 0. So applying, therefore, fz by z minus z0 dz is equal to 2 pi I into f of z0. And by extension of Cauchys theorem is f dash nth differentiation of fz is equal to factorial n by 2 pi I into integration fs by s minus z into n plus 1 dz. And also at a point z is equal to z naught, nth differentiation z0 is equal to, in place of z we can write z0, in place of z we will write z0, and also here also z minus z in place of z. Z is a general point. Therefore, here the general point is f of s, here general point is fz dz. This is the nth differentiation at z is equal to z naught. Here we will see some applications or problems. Uh, by using Cauchys integral formula, find integration of e power 2z by z power 4 into dz, where the simple closed curve is mod z is equal to 1. That is, 0 is center and radius is 1 here for a unit circle. The vector is 0 with radius 1, mod z is equal to 1. We write the first Cauchys general integration formula, that is nth differentiation of the function at z is equal to z0 is equal to factorial n by 2 pi I into fz by z minus z0 power n plus 1 dz. So n is equal to 1 to infinity, 1 to infinity. So z minus z0, so this part is this one into 2 pi I into f of n0 by factorial n. So here our n is equal to n plus 1 means we have to find z power 4. So n is equal to 3 here. So the function is e power 2z. The function is e power 2z, and the point is z0 is equal to 0 and n is equal to 3. So, and the third differentiation we have to find third differentiation. Therefore, f dash z is equal to 2 into e power z. So, f double dash z is equal to 4 into e power z, and third differentiation is equal to 8 into e power 2z. So we have to find at z is equal to z naught. So third differentiation at z is equal to z naught, and that is 0. So e power to 0 and substitute z in place of z0 is equal to 0. Z0 is equal to 0. So substitution, after substitution we will get third differentiation at z is equal to z naught, or z is equal to 0 is equal to 2 cube or 8. So by formula integration e power 2z by z minus z0 to the power 4 dz is equal to 2 pi into 2 pi by factorial n into third differentiation, that is 2 cube, that is 8 pi I by 3. So second problem is, if z0 is interior point of positively oriented contour C, then find integration over C dz by z minus z0 whole power n plus 1. So by using Cauchys integral extension formula, we can write f of nth differentiation at z is equal to z naught is equal to factorial n by 2 pi I integration over C fz by z minus z0 power n plus 1 dz. So comparing this one, Here z0 fz same. Here fz is equal to 1. Fz is equal to 1. So in this problem fz is equal to 1. Fz is equal to 1 and n is equal to n is equal to n and z naught is equal to z naught only. Therefore, we find fz is equal to 1, that is f dash z is equal to 0 and f double dash and after all differentiations will become 0. Therefore, f dash z0 is equal to 0, f nth differentiation at z is equal to z naught is equal to 0. Therefore, substitute the integration formula 2 pi I into factorial n. Nth differentiation is here 0. Therefore, this will become 0. Prove that integration 1 by z minus z0, before that z minus z0 whole power n plus 1. We have first here z minus z0 only power n. Therefore, at n is equal to 0. Cauchy's integral formula is f of z naught is equal to 1 by 2 pi I into fz by z minus z naught dz. Here fz is equal to 1, fz is equal to 1, fz is equal to 1 and f of z naught is equal to, the point is at z naught only, fz is equal f of z naught also 1. Therefore, integration 1 by z minus z naught over c dz is equal to 2 pi I into f of z naught. F of z naught is equal to what? That is 2 into pi I. Note that here n greater than or equal to 1, this integration becomes 0. So, here we have found that n greater than or equal to 1, n greater than or equal to 1, this integration is 0. And similarly, all these formulas here z naught is equal to pi I by 2 and f of z is equal to e power minus z. E power minus z means nth differentiation is fz is equal to e power minus z and nth need to find nth differentiation. Here n is equal to only 0. N is equal to 0. Therefore, the formula is by this formula. The formula is 2 pi I into f of z naught. Here f of z naught is equal to pi minus pi only plus pi I by 2, plus pi I by 2. Therefore, f of z naught is equal to e power minus pi I by 2 is equal to cos pi I by 2. We can write De Moivre's theorem. So cos pi I by 2 minus I sin pi I by 2. So this is 0 and this is 1 minus I. Therefore, this integration is equal to 2 pi I into f of z naught, that is 2 pi I into e power f of z naught is equal to minus I. Substitute minus I here, we will get to 2 pi. And here also this is 2 power z, we should write that z minus z0 type. Therefore, take common 1 by 2, so we will get z plus half, z by z plus half. Therefore, here fz is equal to z, fz is equal to, and the numerator fz is equal to z and z naught is equal to minus half. And f of z naught, substitute z naught here, f of z naught is equal to, in place of z, we will get minus half only. F of z naught is equal to minus half. Cauchy's integral formula, as we know that, Cauchy's integral formula is 2 pi I into f of z naught. So, substitute here 2 pi I into f of z naught is equal to minus half. Minus half into 2 will get cancelled. Therefore, we get